Alright, so today we're gonna be going over all formulas and equations in Calculus 1. So essentially this video is gonna be all the formulas that you would need to know in Calculus 1, and we'll go over why they are and what they do. But one thing we won't go over is the questions relating to the formulas, rather practice. And if you want to get practice on that, I have videos on all of these topics. So let's start with the first one, the most basic one is going to be limit as x goes to 0. We have f of x plus h minus f of x over h. This is basically a way to find the derivative of a limit using the x plus h little equation right here. What you would do is, let's say you have x2 plus 6. Let's say you plug it into here. So you would have f of x, that would just replace f of x. And then x plus h would replace the x values in the function, and you would write it out and essentially find the limit. And the second one over here to the right we have is going to be this slope. So this is essentially the limit as x goes to a number, and this equation right here will give you a secant value from a to another interval of b. So it's essentially the slope of the secant line, and a secant line is just a line from one point to another. And now we have the power rule. The power rule is where we get into actual derivatives now. So the power rule is the most simplest form of deriving a function, which is going to be a variable to the n power, which is just going to be a number. The derivative of that is going to be, you would bring the n out to the front, and then you would subtract the exponent by 1. So let n be any real number. And then we have the product rule, another form of deriving a function. Let's say you have f of x times g of x and you need to find derivative. Since they're being multiplied, you got to use the product rule. By the product rule, you're going to have to take the derivative of f multiplied by g and then add it to the function f of x multiplied by derivative of g. Alright, now we have the opposite of the product rule. We have the quotient rule. This is when two functions are being divided in a fractional form. So the derivative of f of x over g of x would be f prime of x, f prime being derivative of f of x, f prime of x times g of x minus f of x times g prime of x. One good thing to note is that in the quotient and the product rule, the top, or it always starts with f prime g, and then for the quotient rule it'll be minus, and then for the product rule it'll be plus, and it would be f of x times g prime of x. So it's always going to be the same. The quotient rule is just minus, and the product rule is a plus. But in the quotient rule, we also have a fractional form in which the denominator is going to be g of x squared. So it's going to be the function value when you plug in x into the function g of x, and then you're going to square that. And now we have one of the most popular rules of deriving, which is going to be a chain rule. So let's say you have derivative of f of g of x. In order to find the derivative of that, you would have to get f prime of g of x and then multiply it by the derivative of g of x. So something like that would, let's say you have like x3 plus 4 to the power of 5. So x3 plus 4 is going to be your g of x, and then 5 is going to be your f of x. So it would, if you replace x3 to plus 4 with the variable, let's say u, it would be u5. That would be like your f of x. And now let's go to some like rules to know, some general, answers. So ln of e is always going to be 1, ln of 1 is 0, sine 1 is going to be 0, or no, sine 0 is going to be 0, and cosine 0 is always going to be 1. And now we go on to trig derivatives. So these three derivatives in trig functions is very important to memorize. So derivative of sine of x is going to be cosine of x. The derivative of cosine of x is going to be negative sine x. And then derivative of tan x is going to be secant squared x, which secant is essentially 1 over cosine. So it would be 1 over cosine squared. And then this is also pretty important to know. The derivative of the first derivative of f of x is going to be the second derivative of f of x. So derivative of f prime of x is f double prime x. And now we go on to some more trig derivatives. So for these derivatives, you don't necessarily need to memorize them, as you can derive them from the other trig functions, but you could also memorize them. So derivative of secant x is going to be secant tan x. This is one derivatives you get asked the most. Cotangent x is going to be negative cosecant squared x. And then cosecant x is going to be negative cotangent x multiplied by cosecant x. So cotangent and cosecant x, they really aren't asked that much, but it's still good to memorize it. Secant x is actually asked the most in my past experience. And so we have here log and ln differentiation. So derivative of log b x would be 1 over x ln of b. So b would be whatever's down here, and then x would be whatever's in the parentheses, and it would be a denominator of 1 in a fraction where numerator is 1. And then this is a little bit simpler, so derivative of ln of x is going to be 1 over whatever's in the parentheses and then multiplied by derivative of whatever's in the parentheses. So in this case, it would be ln of x. Derivative of x is going to be 1, but it's important to know that sometimes when the derivative of the inside is not 1, you're going to need to multiply by that. And especially in implicit differentiation and different types of questions, you're going to run into like d over dt, d over dx, dy over dx. These are some important rules to know, and especially when you format your question and answers. And now this is linear approximations. So linear approximations is another way of figuring out complex answers. So let's say you had square root of 3.99. By hand, you can't exactly do that, but using linear approximations, it's possible to do that. So the equation for that is going to be L of x is equal to f of a plus f prime of a, and in parentheses x minus a. All right, now we're moving on to a little bit of visualization of graphs. So these are some important rules to know. So the zeros of the function f of x is going to be when f of x is equal to 0. Now the zeros of the function f prime of x is going to relate to the maximum and minimum points of the function f of x, and it's essentially when the graph changes direction. And we could actually see it down here. So the zeros is going to be when it hits the x-axis, and f prime, the zeros of the f prime function is going to be essentially, the max, the highest, and the lowest points of the graph. And the concavity changing, so for f of x, when the concavity changes, it's basically the maximum minimums of the derivative function or the zeros of the second derivative function. So what that looks like when the concavity changes, it's essentially when the acceleration or a second derivative vector is changing sign. So it's going from positive to negative or vice versa. So we could kind of see over here the acceleration is positive as it's accelerating because it concave up, and then it starts decelerating, so it's concave down. So concave up is when the graph makes like a U shape. Concave down is like a upside down U. So you could kind of think concave up is like graph kind of goes like that. Concave down, it's kind of like that. And yeah. Now we move on to the mean value theorem. So the mean value theorem is essentially finding the average slope within an interval. So we would have in that interval of a to b, we would have f prime c is equal to fb minus fa over b minus a. And usually you would plug those in to find f prime c, and sometimes you would have to plug in and find a value of c in the derivative function. And the Rolle's theorem is exactly the same as the mean value theorem about just the only difference is that in Rolle's theorem, for Rolle's theorem to apply f primacy, it must equal 0. So if f primacy doesn't equal 0, then it automatically just deals with the mean value theorem. And now we go on to the Hospital rule. So Hospital rule is essentially, let's say we have limit as x goes to a of f of a over g of a. Now, what we could do is on the numerator, we would find f prime of a, so derivative of function f of a, and g prime of a, and we would divide those together. And if we get a whole number or, in a determinate number, then we leave it. Otherwise, we use the Hospital rule till we get determinate number. Some examples of indeterminate forms would be if we get 0 over 0 or infinity over infinity. And let's say you get f prime of a over g prime of a. Let's say you get like 5 over infinity. In that case, you can't exactly write 5 over infinity because that's not a definite answer or determinate answer. In that case, your answer would be 0 because 5 over an infinitely increasing number or bigger number is going to be 0 because denominator is getting infinitely larger. And some noteworthy rules to know as well is that any number over 0 is going to be does not exist, and then 0 over any number is going to be 0. Even like 0 over infinity and infinity over 0 is going to be does not exist. And now we go over Newton's method. So Newton's method, the formula for that is going to be xn plus 1 is equal to xn minus f of x over f prime of x. So essentially what Newton's method deals with is, let's say you're given an original approximation of a 0 to be like 2, and you need to find x2. What Newton's method is going to do is it's going to give you an approximation closer to 0 of the function. So let's say a 0 of the function is going to be 0, or it could be a -1 as well. And let's say you plug in x1, your x2 value will always be closer to 0 or -1, which is an actual 0 of the function. So this is essentially this formula, or rather equation, helps you find the roots or zeros of a function. And now we go on to U substitution, which is basically an introduction to antiderivatives and integration, which it leads away from derivatives. It's also kind of like the opposite of derivatives, or opposite of differentiation or deriving a function. So let's say you had integral of f of x and d of x. So to find the antiderivative, or rather the integration of that, you would use U substitution, in which you would give U a value like, let's say we had sine x and then we had cosine. Sine x times cosine x. Let's say you give U a value of sine x, and du, that means du is going to be equal to cosine x dx. And now you have, we could write it out here actually, sine x cosine x integral of dx. So let's say you have u as sine of x and du is equal to cosine x times d of x dx. So you want to get, what you want to do is you want to replace anything you can with u, and you want to replace dx with du and something else. So if we solve for dx with du equals cosine x dx, we divide by cosine on both sides. So we would have dx is equal to du over cosine x. I know this is a little bit messy, but so now if we rewrite this and plug in everything, we're going to have integral of u, because sine of x is replaced with u, and we have cosine x, and then we plug in dx, which is going to be du over cosine x. And we could kind of see a cosine x is, we could cancel them out because they're the same on both numerator and denominator. We cross that out, we are left with integral u du. So essentially that's like your goal when using U substitution. But now you would find the antiderivative of that and then plug in sine of x for u and whatnot. So yeah, that's basically it for U substitution, which is basically introduction to integration. Alright, so that was basically it for all formulas in Calc 1. So this is just a revisitation of everything you kind of need to know in Calculus 1. And in using these equations in like question application, I have videos on every single formula and equation here and every single rule here, so you could feel free to check them out. And as well, most of these especially, it's really important to memorize them because you're going to need them in Calculus 1. And yeah, that's basically it.